Hello everyone, and how are you doing? In this cybersecurity analyst course, today we'll be discussing network attacks. Networks are so important. As a cybersecurity analyst, you should understand what a network is, and we've discussed that in subsequent videos. What networks are, and then why it's important for you to understand how communication happens on a network. Because once you don't understand how communication happens on a network, you can't understand how to defend the network against threat actors and the bad guys and the malicious actors. So every network, in one way or the other, has some inherent vulnerabilities, and this which could be exploited by the threat actors. So every network is more or less a target of a network attack. So how do you secure your network? How do you safeguard it? We need to understand the common types of network attacks and how the bad guys try to intercept networks. So basically, let's talk about the network interception attacks. So what they do mostly is to intercept a network, either by reading up the information and trying to know what the information is so that they can use it for subsequent attacks, or they can delay the attack and replay it again, or they could even do some very important things like stealing valuable information or interfering with the transmission in one way or the other. Or they could pose to be somebody else through identity theft, and then try to make sure the person thinks that is the right person that is actually communicating with them. So threat actors or malicious actors here could use either hardware or software tools to be able to capture and inspect data in transit. This is called the packet sniffing. So packet sniffing is used both by security engineers and analysts, and also the bad guys. You could capture a packet to know what is inside, but the bad guys could also use that. They could capture a packet, try and understand what's inside a packet, and know if it's information that they could still use to be able to cause mayhem. There are different types of attack, obviously, and we have the backdoor attack. In the backdoor attack, we're looking at the fact that threat actors could use the backdoor to be able to get into a network. And let's understand what a backdoor is in the first place. Let's say you have a building, and if you have a building, basically you could just put security doors, cameras. Like a company could have security doors, cameras, and all of those things to be able to check in staffs who go out and who come in, so they can be able to monitor the activities of their staffs and all of that. But in as much as they try to use all of these security tools to monitor the staffs could also find a backdoor, a place that is not being actively monitored, and that is where it could be dangerous. So in every organization, there's always probably a backdoor somewhere that is not actively monitored. If the staffs can locate that place, they can be using that site to come in and then stay unnoticed. So the point is, an employee might walk around security measures to find a backdoor to the building that's not being monitored. Like we said, you could have a building that has several doors, security locks, and all of that. But in as much as you have that, sometimes for safety purposes or thereabout, there could be a backdoor, a place where you can probably escape in case of a burglar attack or whatever it is, and you are inside. You could find a way to escape, which is not through the normal way. That is a backdoor. But for systems, system administrators and programmers always try to fix a backdoor intentionally into the system, and the reason they do this is just to be able to do troubleshooting and to do administrative tasks and all of that. So just like a manufacturer now, if Microsoft creates a software, they could also in their system they could place a backdoor, so that in case you complain of something and there could not be any way to reach out to you, they could just use the backdoor to come in and be able to solve your issue for you. So for troubleshooting, for so many reasons, there are always backdoors on a system. So backdoors is not truly a normal door, but through a means where a network administrator or server is authorized can come in. But the difference between a bad guy and a someone who is doing it with authority or with access control, it's someone it's level of if you have access to it or not. So there has to be permission to be able to gain that form of entrance. So if there's no permission, you're probably a bad guy. So backdoors are intentional weaknesses that are left by programmers or system administrators or network administrators so that they can bypass the normal access control mechanisms that are used for troubleshooting or administrative tasks. Threat actors can intentionally create a backdoor through software that you install in your system. There could be softwares, there could be things that they allow you to install in your system, and from there they could easily create a backdoor and install a backdoor in your system by which they can enter into your system unnoticed and begin to cause so much havoc. That's why it's very, very important that you don't click on any unfamiliar links, you don't click on whatever you don't understand. You don't also it's very important to close all doors that could lead to threat actor coming in. Avoid using USBs that are not authorized. Follow your company's incident response plan in case you observe anything that is wrong. Follow your company's security policies and adhere strictly to all that they say you shouldn't do. If you do that and put all of this security awareness in place, you'll probably be able to guide yourself against a backdoor. The next type of attack we'll talk about is DOS attack, distributed or denial of service attack, rather denial of service attack. Then this is when you target a network and flood it with so much traffic, unwanted traffic. So in the principle of cybersecurity, we have what they call confidentiality, integrity, and availability. What DOS deals with here is the availability of information. So it tries to make the information unavailable to the person who is supposed to receive it at that point in time. So the unavailability of information breaks the CIA triad, which is very important and key for cybersecurity. Now, in DOS attack, this is a type of attack where the attacker try to make the computer system or network resources unavailable. How do they do this? They flood it with so much information, unwanted traffic, so much traffic that it cannot, be able to process all of them at the same time. Then what happens? The next thing for it to do is to just crash or to just make itself unavailable. And once this one happens, the system becomes vulnerable, to other forms of attacks. So just think of a restaurant now that gets flooded with so much people. Everybody's trying to attend to me at the same time. It gets to a point that in order to process all of the orders at once, the system becomes unavailable. So that's the target of a threat actor, to flood it with so much traffic so that it becomes unavailable. And let's look at one or two ways they do this. The first way they do this is through a volume-based attack. So they can overwhelm the target with massive amount of traffic, to a particular point, and then the system becomes unavailable. The next one they can do is what they call the protocol attack, or which we normally call the scene flood attack. When we discuss the TCP/IP model and the OSI model, we're able to talk about the transport layer. And transport layer is very important because it's responsible for transporting information safely to its destination. So it ensures reliability of information that is being transported. In that, we're able to discuss, especially the OSI model, yes, we're able to discuss the TCP handshake, and that is looking at, for a session to occur, there has to be a TCP handshake. Once I make a request from the client, it sends an information to the server, which is a sync information. Sync, that's SYN, synchronized information. So the server will respond that I have received the information, and it's going to respond with the SYN hack, that's synchronize and acknowledgement. So once it responds to the sync hack, it's telling you that okay, I've acknowledged what you said, and yeah, I'm going to respond to you. I'm telling you to also open up so that I can be able to send information to you. So once you send a SYN hack, it will open up its own port in the server so that it can also receive back from the client, and a session is being established. So if you understand that process, then the threat actors can be able to manipulate that process. That's why we said it's important that a cybersecurity analyst is able to understand the process by which attack occurs, and be able to understand how network happens, how communication happens on the network. But once you understand the fact that a three-way handshake can be manipulated, then you know the fact that TCP attack can also occur. So with the SIM flood attack now, what it does is to exploit the weaknesses in the network protocol of TCP and the session layer protocol. So what it now does is very simple. Once the client sends information to the server, what it does is to make sure that it sends so much than what the server can receive, and at every request, once it makes a request, it's going to return back the request to the client and say, okay, I've seen your message, I'm going to respond. So what they will now do is to kind of redirect the message. Instead of going back to the client that asked the question, they will redirect it to a different place entirely. So it keeps waiting and waiting, and they are sending more requests, it keeps waiting, they're sending more requests, it keeps waiting, they're sending more requests, it keeps waiting. And by doing that, it becomes overloaded with so much resources that it becomes unavailable.